All right, now we get to problem number 9. What happens when you're not given an angle? Okay, in problem number 9, we're given an A value of 3, a B value of 4. To find C, find side C, we can use Pythagorean's theorem. 3 squared plus 4 squared should equal C squared. Okay, that's 25. So C then must equal 5. Okay, we also know that the biggest angle, our right angle, is 90 degrees. So how do we find A and B? Okay, well, let's look at what we have. We have this side is 3, this side is 4. We also know that this side up here is 5. We just found that. Okay, so we're looking for this angle and this angle. I suggest you pause the video and see if you can figure it out at this point. Okay, if not, I'll show you here in a second. Okay, so I'm looking for angle A, and if I have the opposite side over the adjacent side, I know that involves tangent. Okay, I know that the tangent of angle A is going to be the ratio 3 over 4. It has to be, because that's what we know about tangent. Okay, now when we have a ratio and we're looking for an angle, we want to use the inverse. So I'm going to take the inverse of 3/4, and that will give me angle A. Similarly, if I want angle B, okay, to find angle B, it's also going to be the inverse function. But now angle B has an opposite side of 4, an adjacent of 3. So angle B is going to equal the inverse tangent of 4 over 3. Okay? So if I do those calculations, if I take the inverse tangent, 3 over 4, I get 37 degrees, 36.9 degrees. And if I take the inverse tangent of 4 over 3, I get 53 degrees. Now, a couple checks you can always do to make sure you know you have the right information is these three angles should always add up to 180. So 36.9 plus 53.1 plus 90 equals 180, and it does. Okay, another quick check is that your small side should always be across from your smallest angle, your middle side across from your middle angle, your biggest side across from your biggest angle. Okay? And Pythagorean's theorem should always work in a right triangle. All of your ratios should always work. So really, you shouldn't be able to get one of these wrong as long as you check that you have all of your ratios working. And maybe it takes a little while to check all those. Like, for instance, sine of 36.9 should be the opposite of angle A, which is little a, divided by the hypotenuse. So if you put this in your calculator, you should get 3/5. Sine of 36.9. If you put the cosine of 36.9, you should get 4/5, and so on. You're going to have to put in exactly what this is instead of the rounded 36.9, but it'll give you a good approximation. Hope this helps.